Dear friends, welcome back to my YouTube channel, MCB ChemTube. This is an online chemistry tutorial, and you get my previous videos from my personal homepage or from my YouTube channel. And we were discussing about the topic chemistry of functional group second, and today we are going to discuss the functional group amine, its preparation, and two reactions: Hofmann Bromamide reaction and Hofmann Carbylamine reaction, and the basicity of amines. So our learning objectives are to understand the preparation of amine from nitro compound and two reactions of Hofmann Bromamide and Carbylamine reaction. Also we will compare the basicity of ammonia, methyl amine and aniline. Coming to the introduction of amine, amines are nitrogen containing compound which may be considered as derivative of ammonia. And hydrogen of ammonia is replaced by, in some cases, by alkyl group or by aryl group. And ammonia can be classified into primary, secondary and tertiary amine based on degree of substitution at nitrogen. Primary amine, in the case of primary amine, one hydrogen is replaced by alkyl or aryl group. In the case of secondary amine, two hydrogens are replaced by alkyl or aryl. And tertiary, all hydrogens are replaced by alkyl or aryl group. And in this case, this is an example for primary amine. And this you can see the amine N is attached to a one carbon atom. So it is primary amine. Whereas if you have an OH group here, it is a tertiary alcohol. And in the case of alcohol, this classification is based on the degree of substitution at carbon. Whereas in the case of amine, the classification is based on degree of substitution at nitrogen, not the carbon. Right? And next one is nomenclature. The generic name of amine, you can say, you can name it in two ways. You can name as an aminoalkane, aminoethane, aminopropane, or aminobutane. Or in another way, the second way is the E at the end of hydrocarbon, that is ethane. The end E can be changed to amine. That means ethanamine, propanamine, butanamine, and pentanamine, hexanamine, like that. And next, the amine group is located by the position number. You can locate this amine by position numbering. And first to find out the parent chain. In the case of this compound, this is 1-butanamine. The amine is at the first position, right? And sometimes there will be more than some groups that attach to the nitrogen that should be located using N as the position number. That is, in second case, this is in this example, this is parent chain, and amine is located at third position, and you have another derivative here, so that should be written by using N, that is N-ethyl 3-hexanamine. And next example, you have an alkyl derivative, that is N-ethyl and N-methyl. So we have to tell first ethyl based on alphabetical preference. N-ethyl and methyl 1-propanamide. That's about naming. Next one, preparation from nitro compound. And nitro compounds can be reduced to amine, but by catalytic hydrogenation, that is a hydrogen and platinum catalyst, you can use, or by chemical reduction using metal and acid, that is some metals like tin and HCl, and using basic solution, you get this nitro get reduced to amine, and you can see it here. This is nitro compound is reduced to amine, and in this particular base, this nitro is reduced to amine, and by using tin and HCl also, nitro is reduced to amine. And aniline is prepared from nitrobenzene by using the metal and acid tin and HCl. And we can also use catalytic hydrogenation using platinum oxide or nickel or iron HCl and basic solution or iron metal in refluxing acetic acid or platinum on carbon and zinc dust and formic acid. These are the other catalysts that can be used for the reduction. And next reaction is Hofmann Bromamide degradation reaction. And this reaction is named after its discoverer August Wilhelm von Hofmann, and this is a Hofmann Bromamide reaction. Sometimes it is called like this, or in some cases of you can see bromide degradation reaction. This is an example for degradation. And what is Hofmann reaction? It is a conversion of, you can see from its name itself, you can understand, is an amide is converting an amide into amine, primary amine. So conversion of amide into primary amine by using bromo in the presence of bromine and alkali. So the product will be having, this is most important, one carbon less. So a degradation reaction occurs. So the reaction requires 3 equivalents of alkali. So we are starting with an aliphatic amide. Suppose with bromine and alkali you get amine. So this CO get released out of from here and NRNH2 you get. So a degradation reaction is an example for a degradation reaction. And for example, if you are using benzamide, this is an aromatic amide with bromine and alkali, you get aniline. Or acetamide or ethanamide with bromine and alkali, you get methanamide. So one carbon less in product you can see. And the reaction of primary amide with bromine and sodium hydroxide transform into an intermediate first, and this is intermediate, this is called isocyanate. And this isocyanate, the intermediate isocyanate is hydrolyzed into primary amine. And this is useful for preparing descending homologous series. You can, the descending homologous series can be prepared by Hofmann Bromamide reaction. For example, propanamide with bromine and alkali, you get ethanamide. A descending series you get. And in this particular example with bromine and alkali, you get the CO get released out of it, this amide, you get corresponding acid, that is alpha orthoaminobenzoic acid. It is also called anthranylic acid. That's about Hofmann Bromamide degradation reaction. And next one, carbylamine reaction. It is also called Hofmann isocyanate synthesis. And what is carbylamine reaction? So please remember that, please listen, it is an alcoholic solution of primary amine. You can use aliphatic or aromatic amine. And this primary amine react with chloroform. Okay, remember chloroform in the presence of base to yield the product isocyanate. It is also called carbylamine. That is why it is called Hofmann isocyanate reaction. And via an intermediate dichlorocarbene. So if you know the mechanism, it gives the product isocyanate or carbylamine via dichlorocarbene. And this reaction is used for qualitative test for primary amine. Okay, so carbylamine reaction only gives by primary amine. It does not react with the secondary or tertiary amine. And moreover, the most important thing is an isocyanate product is you can readily note it by its nauseating odor, very bad smell it gives. So you can test primary amine by identifying this order, initiating order. And this is the reaction scheme. Ethylamine with chloroform and alkali alcoholic solution, it gives isocyanate, ethyl isocyanate. And if you are using aniline with chloroform or alkali, you get phenyl isocyanate. And this is the mechanism of reaction. Chloroform with alkali, the presence of alkali, and this is a base, alkali is base. So this hydrogen is a little bit acidic because of this 3 electron withdrawing group. It forms a carbanion because it is an acidic. It gives off H plus, and H plus react with OH minus, it releases water and it forms carbanion. And in this carbanion, it leave, Cl minus will leave, an intermediate trichlorocarbene will be formed. And aniline or any primary amine react with this dichlorocarbene, it forms an adduct like this. It's a nucleophilic substitution reaction. And this is an electrophile. And this contains only 6 electrons. And this proton can give off its proton, nitrogen can give off this proton to anion, this carbanion, and you get this corresponding product. And HCl can be removed, the Cl minus can be removed from here, and it forms this product, and finally give off this H plus, and it forms a product like this. And then finally another again a Cl minus will leave from here and it form a product like this. Then in the presence of base, this can abstract again this H plus and it form isocyanate. This is the mechanism of carbylamine reaction. And next one, the last topic, basicity of amine. And generally amines are weaker bases, but it is stronger than water, but at the same time weaker than OH minus, hydroxyl anion. And we have to compare the basicity of amine, ammonia and aliphatic amine and aromatic amine. So in the case of aliphatic amines, that is methylamine or ethylamine, and this is methylamine, and this is ammonium and methyl ammonium. And in the pKa of its conjugate acid, actually ammonia, after taking up a proton, it forms its conjugated acid. This is the conjugate acid of ammonia. And the pKa of ammonium is 9.26. And methylamine, that is aliphatic amine, after taking up the H plus, this is a acid-base reaction, it forms its conjugate acid, and the pKa of its conjugate acid, that is this one, is in the range 10 to 11. And you can see that these are slightly stronger than the ammonia. And what is the reason for the basicity of slightly stronger basicity of ammonia, the methylamine, than ammonia? The increase in basicity is due to the stability of its conjugate acid. So we are telling the basic strength based on the stability of its conjugate acid. So in this particular case, aliphatic amine, you can see that this ammonium has a greater stability. Do you know why? Because this is positively charged, and this alkyl group is a plus I group. So it can donate electron density towards this direction, towards this electron deficient area. So the charge can be delocalized over the whole molecule. So the increase in basicity is due to greater stability of alkyl ammonia with ammonia. Why it is greater stabilized? The positive charge is partially delocalized onto the alkyl group. Why it is delocalized? Because the electron releasing effect of alkyl group can donate its electron density towards this positive center, which can result in delocalization of the positive charge. When you have a more electron donating group like ethyl, and you can see that it is increasing its basicity. So when you compare the basicity of ammonia and methylamine, you can see that this methylamine is more basic than ammonia. Next we will consider aromatic amine. But aromatic amines are weaker bases than aliphatic amine. What is the reason for that? In the case of aromatic amines, you can see that this nitrogen, the lone pair on its nitrogen is less available for bonding with H+. The basicity means the availability of the lone pair on nitrogen. If it is more available, it will be more basic. But in the case of aromatic amine, you can see that there is a resonance, and due to the resonance, this lone pair on nitrogen is in conjugation or in communication with the aromatic benzene ring. That you can see here. I've shown here. Lone pair can bond with this aromatic ring like this as shown here, and you can see that this is double bonded, and this will be having carbanion structure. Again, this transfers electron towards this direction and double bond break, and so again it get a carbanion character, and again this bond break, and you can see that most of the time this nitrogen is positively charged. That means there is a less electron density here. So because of the interaction of electron pair on nitrogen with the pi system of aromatic ring, this nitrogen lone pair is less available. So it is less basic. So resonance stabilization of the base form of amine can decrease the basicity. And second thing, this is the conjugate acid of this aniline, that is an anilinium ion. And this conjugate acid having a less resonating structure. So if you have a more resonating structure, that will be highly stabilized. But in conjugate acid is less stable than aniline, that is its base. That means conjugate acid is having only two resonating structure. This is less stable. Okay, that's it's very obvious. Okay, right. And this is the exact reason the unshared pair of electron on nitrogen will interact with the pi system of aromatic ring and is less available for reaction with acid. That's the one reason. The second reason, the electron withdrawing effect of sp2 hybridized carbon atom of aromatic ring, that is this carbon atom, this is sp2 hybridized, and this is having electron withdrawing effect. So it can withdraw the electron due to electron withdrawing effect, the lone pair will be less available. So that is the second factor. So when you compare the basicity of aromatic and aliphatic amine, aliphatic amines are more basic. So in summary, we have learned the preparation of amine from nitro compound by catalytic hydrogenation or metal reduction by metal and acid. And we also learned discussed two reactions, Hofmann Bromamide reaction and the Hofmann Carbylamine reaction. Also we compared the basicity of ammonia, methylamine and aniline and found that methylamine is more basic than ammonia, which is more basic than aniline. Okay, that's all. Thank you for watching.